Second goal here was to deal with horizontal and vertical tangents of implicitly defined functions. And we did all this implicit stuff. We did some second derivative stuff. What we're going to do now is we're going to look at this last problem, horizontal and vertical tangents. So remember, horizontal tangents we find by setting the derivative equal to 0. And vertical tangents we find by finding when the derivative doesn't exist. So what we've got going here is we're going to, again, to find tangents, you're always going to use a derivative. So let's find our derivative. So derivative of this thing, how about 50x plus 32y? Oh, and that y is still a function of x, so times dy over dx using chain rule, plus 200 minus, this is the one that people mess with. When they do the derivative of a negative 160y, they think, oh, derivative of negative 160y is just negative 160. But remember, that's negative 160. You brought the power down and multiplied it by 160. So now subtract 1 from the power and then multiply it by the derivative of the inside function. So that y to the 0 is going to drop out of there effectively. And what we're going to end up with then is negative 160 dy dx. Derivative of 400 is 0. And, of course, the derivative of 0 is still 0. So what we have is our derivative. Let's rearrange it. We've got a couple of terms. Let's move the 50x to the other side, and let's move the 200 to the other side. And while I'm at it, I'm going to factor out the dy over dx of my 32y minus 160. And that's equal to negative 50x minus 200 after I rearrange. So my derivative, negative 50x minus 200 over 32y minus 160. Okay, so there, we've done that. Now, looking up at the red and the blue, if I want to find horizontal tangents, I want the derivative to be equal to 0. Well, the fast way to set the derivative equal to 0 is to say, so this is my horizontal. I'm going to set dy over dx equal to 0. Well, the fast way to do that is to set the numerator equal to 0. And over here, I'm going to find my vertical tangent. Well, my vertical tangent, I'm going to find out when the derivative doesn't exist or is undefined. Well, the fast way to do that is to set the denominator. Whoops, 32y minus 160 equal to 0. So that's the case. Now what we've got to do is a little quick algebra. So the red function, we're going to find out this is going to happen. Add 200, divide by 50, so x is going to be negative 4. And the blue function, add 160, divide by 32, y equals 5. So now the thing I want to caution everybody against is there is absolutely positively nothing going on at the point negative 4, comma 5. They are not related. They are totally and completely separate. So we got to think about them that way. So now, if we look back at the original problem, it says find the point. Points, by definition, have an x-coordinate and a y-coordinate. So I have the x-coordinate of my horizontal tangents. Now I need to find the y-coordinate. Well, how do you find the y-coordinate? You're going to plug x into the original function. So I'm going to have a tough time doing this because it's all the way up at the top of my screen and I got it right on the bottom. So I'm going to plug negative 4 in everywhere I see an x, and I'm going to leave y. So negative 4 squared is, so I've got 25 times 16 plus 16y squared plus 200 times negative 4 minus 160y plus 400 is equal to 0. So when I finish solving this, wait, 25 times 16, I think that is 400. 200 times negative 4 is negative 800, plus 400. All those constants are going to drop out. What I've really got is 16y squared minus 160y is equal to 0. Factor out a 16y, and I've got a y minus 10. So what I have for horizontal tangents, they're going to happen at the point, it looks like y is going to end up being equal to 0. Sorry. It's like y is going to end up being 16y equals 0, y equals 0, y minus 10 is equal to 0, y equals 10. So what I have horizontal tangents at the point negative 4, 0, and negative 4, 10. So there's my two horizontal tangents. My vertical tangents, I'm effectively going to do the same thing, but now I'm going to use my, I'm going to plug 5 in place of y. So I've got 25x squared plus 16 times 25, that's that same 400, plus 200x minus 160 times 5 plus 400 is equal to 0. So if that's the case, 25x squared, let's see, 16 times 25 is 400, 160 times 5 is negative 800, plus 400, the constants are going to drop out again. Isn't that nice? Well, now I can take out a 25x, and there's an x plus, I think that's an 8, is equal to 0. Set your quantities equal to 0, so 25x equals 0, x comes out to be 0, x plus 8 equals 0, x comes out to be negative 8, and I now have vertical tangents at the point 0, 5, and negative 8, 5. So to answer my questions, where do I have horizontal and vertical tangents, or the points? Find your values by setting the derivative either equal to 0 or finding where it's undefined, and then go back to the original function to come up with what your partner coordinates are.